Niels Bohr, the architect of the atom, 1885 to 1962. Copenhagen, 1913. A quiet man sat by the window of his university office, scribbling equations across a page already covered in circles and arrows. Outside, the world was still, but inside his mind, the atom was coming alive. His name was Niels Bohr, and he was about to give shape to the invisible. Born in 1885 in Copenhagen, Denmark, Niels Bohr grew up in a family of science and philosophy. His father, a physiologist, taught him to question everything, to see truth not as an answer, but as a process. From a young age, Bohr was fascinated by the structure of matter. What made the world solid, colorful, alive? What mysteries hid in the smallest pieces of existence? He studied physics at the University of Copenhagen, then moved to England, where he worked with Ernest Rutherford, the man who had discovered that atoms contained a small, dense nucleus. But something about Rutherford's model puzzled Bohr. According to classical physics, electrons orbiting a nucleus should lose energy and spiral inward, collapsing the atom, yet atoms clearly existed. How could something so small defy the laws of the visible world? In 1913, Bohr proposed a radical new idea, one that would change science forever. He imagined the atom as a solar system in miniature, electrons orbiting the nucleus, but only in specific, quantized paths. They could jump from one orbit to another, but not drift freely in between. And when they jumped, they emitted light, precise, measurable, and unique to each element. The universe, Bohr realized, was not a smooth flow of energy, but a symphony of leaps. This was the birth of quantum theory, the strange new physics where particles could behave like waves, where certainty dissolved into probability, and where reality itself became a mystery. His model explained the spectral lines of hydrogen, predicted new elements, and opened the door to a new era. For this, Bohr would receive the Nobel Prize in Physics, 1922, but his work had only just begun. Bohr's laboratory in Copenhagen soon became a sanctuary of science, a gathering place for the brightest minds of the century: Heisenberg, Pauli, Dirac, Fermi, and even Einstein himself. There, they debated the nature of reality, not in anger, but in wonder. Einstein, a man of certainty, would protest, "God does not play dice with the universe." Bohr, smiling softly, would reply, "Einstein, stop telling God what to do." To Bohr, uncertainty was not chaos, it was truth. He believed the universe could be both wave and particle, order and chance, that reality depended on observation itself. It was a philosophy as much as a science, that to know the world, one must also accept mystery. During World War II, Bohr's Denmark was occupied by Nazi Germany. As a half-Jewish scientist, he was forced to flee, smuggled out of the country in a small fishing boat, carrying his theories in his head. He reached Sweden, then America, where he joined the Manhattan Project, reluctantly helping to harness atomic energy, not for discovery, but for war. After Hiroshima, Bohr was haunted by what science had unleashed. He spent the rest of his life advocating for peaceful use of nuclear energy, urging nations to share knowledge, not weapons. Every great and deep difficulty, he said, bears in itself its own solution. Niels Bohr died in 1962, leaving behind not only equations, but a way of thinking, humble, paradoxical, and profoundly human. He taught that the closer we look at nature, the more it reminds us of ourselves, complex, uncertain, yet full of light. To the world, he was a physicist. To history, he was the architect of the atom, the man who gave shape to the invisible, and showed that truth lives not in absolutes, but in balance.